Here we're talking about some descriptors of a function or some sort of graph. When we're looking at a graph, we can tell a lot of different things, and there's a lot of different descriptors that we use. We chose a couple to look at here, like minimums and decreasing and concavity and points of inflection, but there's a lot of things that we can look at, like domain and range and all of that sort of stuff as well. So I just make sure that we know all those different pieces if we're ever looking for, ideas or understandings about our graph. So the first thing here that we're talking about is the global minimum. The global minimum means it's the lowest value, the lowest y value on the entire graph. So this point right here is a minimum, but it's not the global minimum because there's a point that is lower than it. And so in this case here, this is my global minimum. And the way that I can write that would be -2, -4, because that is the coordinate or the point where it is the lowest on our graph. Second thing is intervals of decreasing. So notice, first of all, if we're reading carefully, it says intervals, meaning there's probably multiple. So decreasing means that as we go to the right, we are going down. So if I were to follow this graph, right, I see that this first part of the graph is actually where it is decreasing. But once it hits that purple point, then it starts to increase here. But then once we hit this point here, we're now back to it going down. But then we hit this point here, and now it's increasing again forever. So really, I'll just shade this here. We have this part here is where it is decreasing, and this part here as well. So that's where my two intervals are. When I am talking about an interval, this is important, is the interval is where is it decreasing, and where is always going to be talking about the x values. So we say for this first section here that from -infinity, because it goes on forever to the left there, all the way to -2, it is decreasing. Then I'm going to use union here because I'm talking about two different intervals here that are both decreasing. It starts back up at 0, that's right here, and it's decreasing all the way to the x value of 3. So those are my two intervals. The union part is not as necessarily as important at the moment, but really what it's saying is that it's either this or this here. The intervals, there are two different ones where it is decreasing. Okay, next one, interval where it is concave up. So concave up, that means, let me erase some of this to kind of get a little bit cleaner of a graph again. Concave up, remember concavity is always talking about like if it's a U-shape up or a U-shape down. So concave up is when it's a U-shape up like this because it makes kind of like a U, and down is when it is a downwards U shape. So concave up is U up, concave down is U down. So in this case, when we're looking at it, where is it concave up? I'm going to kind of show you it's concave up in this section here because it makes a U, but really what's important to understand is that at this point right here, it is no longer concave up to the right of that, because if you notice, it's now kind of going down. It's got that, let me just change colors here. It looks more like this along this part right here. And then from there here, another point, let's say right here, is where it changes to being concave up again. So this part here is concave up. So you see that there's two pieces that are concave up and one piece of our function that is concave down. Now, my original question here says, give me one interval where it is concave up. I'm going to go ahead and use the left one here and say that it is concave up from -infinity. Again, where is the x values? So -infinity all the way to -1. So that's the interval that I'm going to use. I could also say, like whatever, 1.5 to infinity. That is another interval where it's concave up, but just this question only asked me for one. Okay, next one says one interval where it is concave down and it's increasing. So first of all, concave down is that orange part that I just highlighted here. And I'm looking for where is it concave down and increasing, and that is only along this section here. because if you remember, like from 0 onward, it is going down, it's decreasing. So the only section that's concave down and increasing is that little pink part there. And if I'm looking for where, I'm looking for the x values. So from -1 to 0. -1 to 0 is the interval where it is concave down and increasing. And the last thing it asks for are points of inflection. And points of inflection are where it changes from concave up to concave down or vice versa. And I've actually already plotted those points on my graph there in green because that's where it changes from concave up to concave down or concave down to concave up. So those 2 points or coordinates here, the first one's -1, looks like -3. And the second one, we're going to kind of have to estimate because my graph isn't perfect, but we'll call it 1.5 and negative, I don't know, 2 1/4 or 2.25. This isn't perfect, but that's just kind of my estimation for what my points of inflection are. And that is all of the descriptors that were asked for about this function. A lot of different things that we could look for here, so a lot of things to pay attention to, but just make sure that you're understanding what the terms mean. So, intervals are talking about the x values, like where is it concave up? Concavity, you got to know what it means to be concave up and what it means to concave down, what it means to be increasing and decreasing, what global and local minimums and maximums are, and then points of inflection where it changes concavity.